Hi dear students, welcome you to the Brilliant group of institution. Today we are here to discuss the most important MCQ from the chapter Biomolecules. You know, this is very easy chapter and a theory based chapter, no numerical, right? So very simple chapter. We can expect a direct question from the chapter for your upcoming term 1 examination. Alright, so I'm starting with the first question from the chapter Biomolecule. Here we have the question, amino acid belongs to which of the following molecular formula? You know, amino acid which contain one amine group and acid group. That's enough to get the answer. Amino acid is the basic fundamental unit of which one? Proteins, right? Proteins are bigger chain. They are made up of so many amino acid. What is the general formula of amino acid? You may study it in the chapter. That is RCHNH2COOH. This is the general basic unit of or basic representation of an amino acid. The R group can be anything, hydrogen, methyl, any group. Depends on that, it becomes different or various amino acids, right? So amino acid is, what's the answer? Can be written here, dear of you, option A, right? Because it contains NH2 group and COOH group on the carbon atom. This is the same situation. But in option B, chlorine is there, no need. Option C, alcohol, and option D, nothing. So amino acid, that's only the matching option is option A. Question number 2. Which one of the following is not a globular protein? You may study proteins are of two types. Protein general classification. What are they? One is said to be fibrous protein. Fibrous protein. The second one is said to be globular protein. Fibrous and globular protein. You know, fibrous, there is in a fiber in nature, they are insoluble in water. Globular proteins, the long polypeptide chains undergo coiling and just converted into a globular, like a spherical structure, right? They are soluble in water. What are the example you studied for fibrous protein? They are keratin and myosin, right? Keratin and myosin. You know, keratin, which where you can identify, that's hair protein, right? Hair, nail, etc. Where you can find out myosin. Myosin is the muscle fiber. What about the example of globular protein? They are insulin and albumin. Insulin and albumin. Insulin and albumin. These are the example. Alright. So which one of the following not a globular protein? What's your answer? What you are expecting? Insulin, all right. Enzyme hemoglobin not belongs to this category. Which one? Myosin. Myosin is actually a fibrous protein, not a globular protein, right? Albumin and insulin only the globular protein. Myosin is not a globular protein. All right. Question number 3. The combination of nitrogen containing heterocyclic base with the first position of sugar is known as. You may have studied pentose sugar, right? This is a pentose sugar and the carbon numbers you know very well, right? Carbon numbers. Here we have, this is the carbon, you can see CH2OH and H. For example, I'm taking a simplest pentose sugar, okay, pentose sugar. And here we have OHH. Okay, just to consider, it is a pentose sugar, alright. And nitrogen containing heterocyclic base with a 1' position means first position. So which is the first position here, all of you? This is the number 1. Number 1, number 2, number 3, 4, 5th carbon. First position, instead of this alcohol, there is a nitrogen containing base. A pentose sugar with a nitrogen containing base in the first position is known as what? Nucleoside. What it is called? Nucleoside. Nucleoside. What is mean by nucleotide? Dear all of you, a pentose sugar with a nitrogen base on the first position is called nucleoside. What is the difference between nucleoside and nucleotide? Nucleotide means on nucleoside, the 5th position is connected to a phosphate group. 5th position is connected to a phosphate group. Then altogether is called nucleotide. Once again, pentose sugar with a base on the first position is called nucleoside. Nucleoside along with fifth position with a phosphate group is called what? Nucleotide. Alright. So here the answer is what? Option D, nucleoside. Next question, all of you. Which of the following pair represent anomers? What is mean by anomer? You studied alpha D glucose and beta D glucose, right? They are the anomers of glucose. In glucose, when you make into the cyclic structure, alpha and beta form are the cyclic structure of glucose. In the cyclic structure of glucose, or the first carbon, C1, first carbon, the configurations are different. OH right side or OH left side. If OH right side, we will call alpha glucose. OH left side, we will call beta glucose. Yes or no? So what is anomers, or how you can identify anomers so easily? Simple one, dear all of you. First of all, anomers in a cyclic form. Okay, anomers are in a cyclic form. And only one carbon configurations are different. Only the configuration of one carbons are different. That is called anomers. See, compound number A. You can see all these are carbon atom, right? Carbon atom. On the first carbon, OH right side. In here the first carbon, the OH left side. Yeah, there is a change. But here the OH group is right side, here again OH group left side. So there are two carbon, more than one carbon configurations are different. So this is not an anomer. Only one carbon configuration should be different. Option B and option C, I can cut it because they are open chain structure, not a cyclic chain. In the cyclic form, we are explaining alpha and beta form. Alright. So in option D, you see these all are carbon atom, right? Carbon atom. In the first carbon atom, OH right side. In the first carbon, OH left side. Yeah, there is a difference. Here OH right side, OH right side, H right side, H right side, OH right, OH right. Oh, no changes. So only one carbon configuration is different and they having same molecular formula, that is called anomers. Option D is the example for an anomer pair. Alright. Next question, all of you, a simplest question. The alpha helix is a structural feature of which one? You may study protein having two type of structure, right? Secondary structure. What are the secondary structure of protein? Alpha helix and beta pleated. Alpha helix and beta pleated. Alpha helical structure actually related to protein. Which term is related to protein? Is it starch? No. Nucleotide? No. Sucrose? No. Polypeptide. What kind of connection is happen in a protein chain? Peptide bond. Polypeptide means it's a long protein chain. Correct. So alpha helix is related to what? Protein, that is polypeptide. Here we have the next question. Dash are joined together by phosphodiester linkage between fifth and third carbon atom of the pentose sugar. You may study that between two normal monosaccharide. Between two monosaccharide, for example, glucose and glucose, glucose and fructose, like that. Between two monosaccharide, what type of force is present? That is called glycosidic linkage. What is that? Glycosidic linkage. Alright. Between two amino acids, other chain, peptide chain. Alright. So between two monosaccharide, the chain is called glycosidic linkage. Between two amino acid, just we discussed now, what's the name? That is called peptide linkage. Peptide linkage. Where you can observe phosphodiester linkage. That you can observe in a nucleotide. Nucleotides are connected. We said no nucleotide. What is a nucleotide? A pentose sugar. First position there is a base. Fifth position there is a phosphate group. This is overall called nucleotide. One nucleotide can interact with another nucleotide to the fifth and third carbon atom, and the bond between two nucleotides is called phosphodiester linkage. Okay, phosphodiester linkage. So phosphodiester linkage is in between nucleotides. Option D is the correct answer. Next question, all of you. When a nucleoside is linked, what is a nucleoside? A pentose sugar. First position, there is a base. Nucleoside is linked to phosphoric acid or phosphate group. What it is called? We will call it as nucleotide. A nucleoside is linked to phosphoric acid. Which of the following can be obtained? That is nucleotide. Hydrolysis of protein in the presence of enzyme produces. Dear all of you, proteins are made up of so many numbers of amino acids. So when protein hydrolyzes, what you will get? Amino acid, right? Option A. Hydrolysis of protein results amino acid. Next one. The most appropriate base pair in double helix of DNA. You know DNA having a double helical structure, right? Double helical structure. One strand is 5' 3', other will be 3' and 5'. In one strand, they are complementary each other. If in one strand you have adenine as a base, the other strand definitely it is making pair with thymine through a double bond. Adenine thymine is the base pair, and similarly if one strand contain guanine, other strand definitely it should be cytosine through a triple bond. Guanine and cytosine are connected through a triple bond. Alright, so what are the base pairs? What are the base pair in DNA? Adenine with thymine, guanine with cytosine. So which is the most appropriate base pair in the DNA? That is adenine and thymine. Guanine and cytosine is there? No. Then each polypeptide in a protein has amino acids, right? Protein contain amino acid. They are linked with each other in a specific sequence. This sequence of amino acid is known as whether primary structure, secondary structure, tertiary structure or quaternary structure. We may study the specific and sequential arrangement of various amino acids on a protein chain is called primary structure of protein. What? Various amino acids are arranging in a specific and sequential arrangement in a long polypeptide chain is called what? Primary structure of protein. This is the definition of primary structure, right? See, in a polypeptide chain on a protein, amino acid is there. Yeah, these are amino acid. Their specific sequential arrangement is known as what? Primary structure of protein. What about secondary structure? Two type, right? Alpha helix and beta pleated structure. What about tertiary structure? Secondary structure undergo further coiling, you will get tertiary structure. What about quaternary structure? Some proteins are made up of different protein chain, like a peptide chain. Right? Peptide chain. So one protein, other protein. They are called it as subunit. Their arrangement is called what? Quaternary structure. So your answer is option B, primary structure. Next one, all of you. Complete hydrolysis of RNA yield. You know DNA and RNA. Which type of compound? They are nucleic acids. Deoxyribonucleic acid, ribonucleic acid, right? DNA and RNA are nucleic acids. When they dissolve, when you hydrolyze, when they splitted, what all species you will get it? DNA and RNA on splitting, it contains total 3 components. One is pentose sugar. Second one is nitrogen contained base, nitrogen containing heterocyclic base, and the last one phosphoric acid or phosphate group. Phosphoric acid or the reacting species is phosphate group. These are common in DNA and RNA, but the compounds are different, right? Pentose sugar part in DNA, RNA are different. Nitrogen bases are DNA, RNA are present. Phosphate is common. So complete hydrolysis of RNA yield, yeah, it producing nitrogen base, it giving phosphoric acid, it giving pentose sugar. Yes, all of these are produced by the hydrolysis of RNA or DNA. Correct? Yeah. Next one. What is the sugar constituent of DNA? Just to be discussed now. DNA, RNA on hydrolysis, it will give you a pentose sugar. What is the name of pentose sugar in DNA and RNA? You may study it. First of all, let me tell you RNA, then we can go to DNA. You may study the structure also. This is very simple to know that. Okay, this is the compound we have. It's a pentose sugar, right? Let me write a pentose sugar in DNA also. This is the pentose sugar. Let me just write the number of carbon. This is number 1, number 2, number 3, number 4 and number 5. Fifth carbon is CH2OH. Fifth carbon. Here again number 1, number 2, number 3, number 4, number 5. The fifth carbon is CH2OH. Okay. Let me just align the components. Okay. This is CH2OH, H. Here HOH. Here HOH. Here we have OHH. This is the pentose sugar in RNA. What is the name of this compound? This pentose sugar is called beta-D ribose. Beta-D ribose. This is the pentose sugar in RNA. What about DNA? DNA, a small change, dear all of you. A small change. What is the major difference between this beta-D ribose and this compound? This side, fourth carbon clear, third carbon, okay. Second carbon atom you can see, here it is a OH group in RNA, here it is H, which means second position doesn't contain oxygen. So second position no oxygen, deoxy. Therefore it is called beta-D 2-deoxyribose. In beta-D ribose, second position no oxygen. That is called 2-deoxy. So this is the name of the pentose sugar in DNA. Come to the question. What is the sugar constituent of DNA? What's the name? Beta-D 2-deoxyribose. What is the answer? D2-deoxyribose. Okay. Names are very important. Here we have, dear all of you, which of the following is an oligosaccharide? You may study carbohydrates. We can classify into 3 types, depends on their hydrolysis. Monosaccharide, oligosaccharide, polysaccharide. Monosaccharide mean they won't undergo further dissociation in water. Example, glucose, fructose, and then something like galactose and ribose. Yes or no? Yeah. In oligosaccharide mean when you dissolve in water, they will give you 2 to 10 number of monosaccharide. If it is giving 2 monosaccharide, you can call it's a disaccharide. If it is giving 3, trisaccharide, tetra, penta, like that. Up to 2 to 10 monosaccharide if they are giving, all together is called what? Oligosaccharide. And polysaccharide mean many number, right? You know, fructose we studied under the category, it is a monosaccharide. Glucose is a monosaccharide. Ribose is a monosaccharide. Only the sucrose is a disaccharide. Sucrose, maltose and lactose we studied under which one? Disaccharide. Sucrose is a disaccharide. What are the 2 monosaccharides in sucrose? One glucose and one fructose. Correct. One glucose and fructose. It belongs to an oligosaccharide. So option D is the correct answer for oligosaccharide. Here, DNA and RNA contain 4 bases each. Let me tell you, in DNA and RNA, 4 nitrogen containing bases are there. What are they? In DNA contain ATGC, adenine, thymine, guanine, cytosine. RNA contain AUGC, adenine, uracil, guanine and cytosine. So DNA contain thymine, instead of that RNA contain uracil. That's only difference. So DNA and RNA contain 4 bases. Correct one. Which of the following base is not present in RNA? Not present in RNA. Which one? Thymine. Thymine is present only in DNA. Alright. Then, on oxidation with a mild oxidizing agent like bromine water, glucose is oxidized too. You may study glucose. Right, glucose on oxidation, 2 oxidation you may study. One is with bromine water, the other one is with nitric acid. Both are oxidation. Glucose, when it is oxidized with a mild oxidizing agent like bromine water, it will give you the product. What is that? Gluconic acid. If you are using a strong oxidizing agent, you know, the upper COOH, below also you will get COOH. There are two carboxylic acid, that is called saccharic acid. Saccharic acid. Alright, here the question with the bromine water. With the bromine water, it will give you gluconic acid. Option C is the correct answer. Now, during acetylation of glucose, it needs X moles of acetic anhydride. What is the value of X? You know the general representation of glucose, CH2OH, CHOH 4 times and CHO. This is glucose. Glucose treated with what? Acetic anhydride. What is acetic anhydride? CH3, CO, O, CO, CH3. This is called what? Acetic anhydride. You know, acetic anhydride can react with the alcohol part, not aldehyde. Anhydride can react with the what? Alcohol. Right. So, what is the product? You may study how to write. It's very simple. The OH and this CH3, COO and H eliminated. And this acetate group is, right, this one. Acetyl group is substituting here. You will get the product CH2O, COCH3. Because there is one alcohol, it will react with one molecule. But here there are 4 alcohol that also will react with the molecule. So you will get CHO, CO, CH3. How many times? Here 4 times. And here we have aldehyde. You may study the name of this compound. This is called glucose pentaacetate. Glucose pentaacetate. Why it is called penta? Because there are 5 acetate group. 5 acetate group. If you want to get 5 acetate group, how many acetic anhydride we have to use? 5 acetic anhydride we have to use. So what is the X moles of acetic anhydride we are using? There are 5 acetic anhydride. Option B is the correct answer. Okay, if you want to do acetylation on glucose, if you want to get glucose pentaacetate, we need 5 acetic anhydride. Alright? Yeah. Next one, a simplest question. The anomeric carbon in D plus glucose is. What is anomers? You know, D plus and D minus glucose, right? Like alpha D glucose and beta D glucose. I'm just drawing the shape of alpha D glucose. This is CH2OH, H, OHH, HOH. Here we have OHH, right? 1, 2, 3, 4, 5. And here also we have OHH. This is the form of which one? Alpha D glucose. What about beta D glucose? Alpha D glucose and beta D glucose are called anomers, right? Anomers. Here CH2OH, here H. OHH, here H, OH. Here OHH. What about the first carbon? Hydrogen right side, OH left side. Right? This is the anomer of which one? Beta D glucose. What is the major change in this one? You know that this is the first carbon, second, third, fourth, fifth and sixth. This is 1, 2, 3, 4, 5 and 6. In first position, if OH group is on right side, we will call alpha D form. If in this first compound, OH left side, we will call beta D glucose. This having same formula, only the one carbon atom configuration is different. This type of isomers are called anomers, right? Anomers. So which is the anomeric carbon? In which carbon configuration is changes? That is called anomeric carbon. So which carbon is anomeric, dear all of you? C1. The first carbon is anomeric carbon in which the configurations of the species are different. Alright. Then we have the question. Alpha and beta form of glucose are, just we discussed. Alpha and beta form of glucose are called what? Anomers of glucose, right? Anomers of glucose. Option C is the correct answer. Next one. Which of the following is not true about a amino acid? Not true about an amino acid. Alright. Option A. They are constituents of all protein. Yes, right. Proteins are made up of amino acid. Correct statement. Alanine having one amino and one carboxylic acid. What is alanine? You know, general formula of amino acid is this one, RCHNH2COOH. What is R here? It can be any group. R group. Suppose R group is hydrogen. I'm just placing R group hydrogen. What's the formula we will get? HCHNH2COOH. Or you can say NH2CH2COH. This is called what? Glycine, the first amino acid, the simplest amino acid. If the R group is hydrogen, we can call glycine. But we need alanine. What is alanine? The R group is a methyl group. Let me place CH3, CH, NH2 and we have COOH. This is called what? Alanine. Okay, come to the answer. Alanine having one amino group. Yes. And one carboxylic acid. Correct. It's a correct sentence. Option C, most naturally occurring amino acids having D configuration. You study D and L configuration. Most naturally occurring amino acids having D configuration. Read NCERT textbook thoroughly. It is very clearly given most of the naturally occurring all amino acids having L configuration, not D. So this is the wrong statement, dear all of you. Okay, option C is the wrong statement. Keep in mind, most naturally occurring amino acids having L configuration. That is correct. Let's go to the last question, all of you. Amino acids are classified as acidic, basic and neutral. Depends on the relative number of amino acid. You know, the amino acids mainly classify into which one? Amino acids mainly classify into three types: acidic amino acid, basic amino acid, and we have neutral amino acid. So simple. Acidic, amino acid contain amine group and acid group. The amine group is the basic group, COOH is the carboxylic acid group. If it is an acidic amino acid, we can say number of acid group in the compound is more than basic group, then more acidic. Basic means the number of basic groups are more than acidic group. Then what about neutral? What about neutral? Number of acid group is equal to number of basic group. Okay, come to the point. Question, which of the following are acidic in nature? Let's go. First compound contain one NH2 group, one acid group. One basic, one acidic. So finally it is what? Neutral. Correct. Second compound, this is an acid, it is a base. Two acid, one base. Finally it become acidic. So question is acidic one. Second one is possible. And third one is possible, dear all of you? No. One amine, one basic, one acidic. It become neutral. Fourth one, yes, two acid, one base. Yes, it is more acidic. So 2 and 4. 2 and 4. Option A. 2 and 4 are more acidic in nature. Clear all of you? Alright, so here biomolecule chapter, mainly we have to focus on first part carbohydrate, second part protein, third part nucleic acids. So it's a very important chapter, and within second we can able to answer, or we can able to attend the correct, or we can able to identify the best or correct answer immediately within this chapter if you just know the theory very well. So keep reading NCERT textbook thoroughly. Whatever the doubts you have, always you can ask to other brilliant faculties. We'll be here to help you. So thank you all. In part 2, part 3 video, we can again meet with so many questions for the chapter biomolecules and for the upcoming term 1 other chapters. Thank you all. Bye.